Thank you. Hello, I'm the backup speaker. Hopefully it's okay. I'm here to talk about being a hater with respect to generative AI. Hi, my name's Phillip. I'm an open telemetry maintainer. I also work for Honeycomb, and I'm actually not an AI hater. I helped build one of our first AI features early last year. I am a hater of badly built AI features, though. So maybe by the end of this talk, you'll kind of feel that way, too. So AI is all the hype, duh. If you've read anything about that, well, yeah, that's what's happening. I think it's actually a little bit shitty, though, that we're in a current environment where you can have major cloud providers post record profits in a quarter and then get rewarded by laying people off. And yet at the same time, we're going to turn right back around and throw a whole bunch of money at AI systems that we don't necessarily know if they're going to pay off. Feels a little weird and discordant to me. And I think probably the best way to summarize this, I wish Cognition Labs well, but a 6-month-old company seeking a $2 billion valuation in this environment feels kind of weird to me. Not really a big fan of that. Being said, though, I do believe that AI is here to stay and for good. I don't think it's like crypto. I think the main difference is that on the crypto side, I would say the majority of the developers took a look at that and said, well, that's a bunch of scam bullshit, and I don't feel like doing anything with that. And on the AI side, a lot of developers are saying, well, there's maybe something kind of interesting here. I'll tinker with it. Maybe I'll even build a feature, and we'll see how it goes. And with that, there is sort of a curiosity that a lot of people bring to this, and they are finding that there are useful things that they can build. And some potential reasons why you might think that it's for real this time is there actually are killer apps out there already today. They are making a ton of money, and it's not just like fake money. It's actual real revenue coming from real people and real organizations. That doesn't mean this whole thing is going to be perfect. We're probably going to face that whole Gartner hype cycle going down kind of situation. But then it's going to come back up, and we're going to have more realistic expectations across the entire market. But it's used by developers. There's a wide variety of systems that are available for you to use. There's strong open source community that's already built around this stuff. And there's already an enterprise ecosystem that, again, is kind of in its earlier stages, but it's there. And you don't have to go looking very hard to find really useful stuff that you can incorporate when you want to build with this stuff. So what I would say, if you might say, well, I'm a little bit of an AI hater, consider augmentation rather than automation. A lot of the stuff is being sold as automation, and that's the bullshit part, because this tech is nowhere near good enough to actually automate legitimate things that people do. But it is good enough to augment a lot of stuff that people do or want to do. And that's where there's that controversial bit of I don't necessarily like how this is being sold, but I do think there's a legitimate technological advancement going on here. And the reality is that it's kind of a step change in capabilities, where in the past, if you wanted to do something say, text to PromQL or natural language to some sort of output that's generally helpful for people, you would have to work for Google or Netflix or Microsoft to get access to the data scientists and ML engineers that could teach you how to build and build this entire system and fine-tune your own model, well, in this case, probably train it from scratch. And that's simply not what you need to do anymore. Now, the world's most powerful machine learning models are a commodity that you can have direct access to. And that doesn't mean that they're going to do the best job 100% of the time, but it's now fundamentally possible for you to call them and do whatever you want, and it can often actually be fairly cheap. Now, that doesn't mean that you're not without problems, and that's what I want to talk about. Because I believe, after working in the reliability space for a few years, and over the past year talking to a lot of ML engineers and a lot of software engineers who don't have reliability or ML experience but are building AI features, that there's a lot of overlap, maybe a 90% overlap, maybe kind of pull that number out of my butt, of cares that people in the reliability space and people in the ML engineering space can have. So let me ask you a few questions. Have you ever said a phrase stop guessing if this will work, and said hey, maybe we should write some tests instead of throwing crap at the wall and seeing if it sticks? You ever looked at a log or a trace before to see what's going on and treated what's happening in production when your users are using stuff as the actual source of truth of what's going on. You said, hey, well, let's make a decision based off of data that we observe rather than just a straight up guess. Have you been suspicious of fixes that you've pushed and said, well, this might not actually fix the thing. Let's look at the data to see if it does. This might regress something else that was working beforehand. Like, I think a lot of people in the reliability space, this is sort of, yeah, of course we're going to be asking these questions. ML engineers ask literally these exact same questions all the time. It's kind of shocking when you talk to an ML engineer just how much they focus on this space. So, congratulations, you're all now AI reliability experts. And I'm kind of not joking about that. So let me give a 10,000-foot description of an actual AI application, not just like some, crap that somebody threw together so that they could scam some people out of some money and get like a paid Substack or something like that. Most people are taking natural language and turning it into JSON. And that JSON, it has to follow some kind of structure that usually is specific to the domain of whatever enterprise company you're working for and whatever system you're trying to plug that JSON into. And the reason why you're typically doing that is because it's very often the case that it's too hard to design a UI that allows for users to effectively create the thing that would then be the JSON that plugs into the rest of the system, or you want to give them an opportunity to express things in ways that they were not able to do so in the past. And I can elaborate on that a little bit. It's almost all of these systems are based off of RAG, or Retrieval Augmented Generation, which is actually a really cool emergent property of language models that was found in the 2020s, May 2020 in particular, where language models traditionally were thought to be these like really cool models based off of a bunch of training data, and they knew about that training data. But they found around that time that if you inserted new information into a request to that model, it can actually kind of act like it knows about that information too. And previous generations of machine learning models couldn't really do that before. So that allows you to do something like take a general purpose language model, such as GPT or Cloud by Anthropic, there's a whole list of them, and you can augment it without having to train your own model with data from your own environment. That's really cool. Adding a whole bunch of context and being able to do this, it makes it a general purpose toolkit that's available for you. But there's a lot of problems with that. So before I get into that, I want to just visually show this. There's lots of different ways that you can slice this up, but at a super oversimplified, high-level way, you basically have the user input, and you want to gather a bunch of context about like what's happening with the user, like maybe their user ID, or if they're in an application where they're wanting to do something with respect to a set of documents or a schema of some kind or whatever it is, like what actually is that information? What are additional contextual things about this user and their request that you can package up in some way? You then want to have this index, it's called a search index. They've been around long before AI systems, but keyword search and things like full text indexing kind of, you can use this as well, but these newer systems have been using what are called vector embeddings of text itself. So you might have, let's say you wanted to answer questions over a large corpus of information that you cannot possibly fit into a single request to a language model. Then you can create what are called vector embeddings of pieces of that information. There's all these problems you have to solve about how you chunk up those pieces of information and how you choose to embed them and so forth. Then you have this database of vectors and you can search them. You can combine different kinds of search techniques. You can combine what's called re-ranking, where you can say, well, we had this one search technique, this other search technique, they produce slightly different results, and we're going to merge the two and sort of figure out an algorithm for what's the best way to merge. That itself may incorporate another machine learning model. Like, there's a lot of depth that this can go into. But the point is that based off of user input, you want to find what is likely to be the most relevant subset of data that you have available that you can augment a language model call with, and you get it to spit out JSON for you. That's, I would wager 90+% of all Gen AI usage in the enterprise today. That is likely to be the case for quite a long time. Okay, so like, just a very brief walkthrough of this. This is a feature that I helped build early last year. It's a natural language to honeycomb queries. Honeycomb is an observability tool, and blah, 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 observability, you query your data. Problem is, a lot of new users come into every observability tool and they go, what the fuck is this? I don't know how to query this stuff. I'm sure you've run into a new engineer who've tried to query something in PromQL and they're like, I hate it. we had the same thing happen with our UI. So we managed to like make that problem a little bit better because a lot of people are like, well, I can express what I want in English. So there we go. And the goal is to look at the dataset schema that they have and then try to figure out what subset of that is going to be combined with any other contextual information that we have and then produce a JSON object that gets turned into what's called a honeycomb query specification, runs on the query engine, all that kind of stuff. What I think is important to highlight is the language model is like the least interesting part of all of this. It's actually not where we spent time when we built this thing. And as I've talked to a lot of people in the industry right now, that's just not really where people are spending their time anyways. And this trace of one of the, like when somebody hit the button, said get query, this is like a trace of what that looked like for one such request that I pulled up this week. There's 26 high-level operations that we tracked in spans through a given trace. And so I say high level, meaning like it's more than just like 26 functions, but like there's a lot of stuff that we have to do because there's a lot of things that can lead to, okay, language model is good enough, but if we don't give it good enough context in the first place, it has no hope of producing a good output. That's like a useful query for someone. And so when we were iterating on this in production over, I'd say like 2 months or so, almost the entirety of our time was spent in these higher level things that are upstream of the language model call. The people who are involved are not ML experts. We don't know the internals of how the language model works, and we don't have to, and that's pretty great. And if there's one point that I want you to take away from all of this, it's that almost every single AI problem out there right now is actually a data and search problem. The models are good enough, and they are cheap enough for most tasks that you actually have. Now, in practice, that can sometimes fall apart depending on if you're trying to build like a super AI agent or like, you know, you're trying to have this model do 1 million possible tasks. And like, we can get into that in terms of like how you effectively build an AI system, and shocker, like anything else in software, if you expand the scope to be a whole lot of stuff, then you're gonna produce shitty features. But if you make it a small enough scope, the models are really, really good at doing specific tasks. And then you spend all of your time on what context you gather upstream of that. And if you don't instrument that, your app is going to suck. Straight up, you need to instrument it because you need to understand user did a thing. What information did we gather for that request? Is it the case that on a per user and per request basis, can that information be different? Not just based off of like the question that they asked, but the context of the state of the system at the time. There's a lot of complexity inherent in this. And I think what's tying back to this whole notion of like, you're all AI reliability experts at this point, like the system is acting weird because a user did a thing. Like that's software reliability. That's not machine learning. That's not like, you don't need to have studied AI to know how to actually make these problems better. And so you kind of are experts in this. So I want to walk you through how you might go about making a better AI app. And I'll start with how you make a bad one. A lot of people do this. You can prototype in ChatGPT until it feels like it's working well. Actually not a bad way to start. Prototyping in ChatGPT is great. This whole feels like it's working well though is a bit of a smell. You can copy paste your prompt into your code base directly. You can use something like LangChain without reading the docs. Deploy it to production and be horrified at what you've deployed. And then retain no users, but then you can write a really cool like LinkedIn post and start a paid Substack and try to get a little money out of this economy. I don't recommend you do this though. There's a lot of AI slop out there. I hate it. You should hate it. Everybody else should hate it. Here's how you make it a little better. You and your team should still prototype in ChatGPT. It's a really, really, really good system for this kind of stuff. You can still kind of do it until it feels like it's working well. You bring it into a separate prompting experimentation repository under source control. Because when you're doing actual prompt engineering and you're saying, okay, these are the ways that we're going to effectively try to talk to this AI model and get it to do what we want to do, you're going to find that there's all these different directions that you can go. And one might seem like it's working better than the other depending on what you're trying to do with it. And you got to tag this stuff. You may release something called a 1.0, and then you release a 2.0 that you think is better, and then it's actually worse. 1.0 is better, and so like there's versioning problems there. The SDLC for this kind of stuff has actually not really been figured out, but Git's not really a bad option for this. You should do that. Log your inputs and outputs, and specifically, there's a point at which you call a language model where you have the full string of information that gets passed to it. So like whatever, maybe you made 100 decisions in gathering context and you packaged it all up into what amounts to just a big string. Log that string. Then after you make the call, you want to log the actual response, and if there was an error, log that as well, and start observing this stuff, looking at triplets of inputs, outputs, and errors, and saying, are there patterns in what these prompts are and what these errors are and what users are trying to do, and use that to actually fix bugs instead of applying guesswork. So visually speaking, you log the full prompt, and maybe you should probably also log the user ID and what their request is, like we can get to that. You want to log any kind of things related to latency, status code, that sort of stuff, and then you get the response as JSON, log that damn thing. You're going to want to really look at that. You may also want to look at token usage and that sort of stuff from a cost standpoint. I guarantee you that cost is probably not going to be an issue. You know, the models are not terribly expensive in the first place, and also your organization has budget for this, so it's fine. You can make your app a lot better than that, though. Yes, I'm a maintainer on OpenTelemetry, but turn your logs into traces. What I'm describing is a request workflow that has a lot of steps in it. That's a trace. That's a distributed trace. I talked to someone who was building an application for a company called Geotag last year, and their retrieval process involved talking to 3 different databases for information. And one of the problems they were trying to solve was, well, are we talking, like, for this request, are we calling the right database for what we're trying to accomplish? And it's kind of hard to know that up front. Really, the only way to start making sense of that is to log this stuff coherently and stitch it together as a trace. So you can start logging upstream retrieval decisions, like what metadata about the user did we gather? Are there user-specific settings that we need to capture? So like in the Honeycomb use case, for example, your schema can have like multiple definitions of what we call an error, and you can set what's called like a canonical definition of an error. So if somebody asks for like, what are my errors? Which error column do we select? That can be driven by context, and so you want to be able to pull that in. If you are calling a database or if you're working against a set of documents, what are the ones that were actually selected to pull information out of? If you had a chunking strategy, as they're called, for divvying up that information and deciding how you're going to do stuff with it, what was the chunking strategy that you applied? If you have a search algorithm, what was the search algorithm you used? It's a lot of information, but you're really, really, really going to want this information when you're debugging this stuff after it's live, because you can't just pull down a language model and debug it yourself step by step like you can other code. Maybe that'll happen at some point in the future, but that's neither here nor there. So then you want to start to look at downstream operations. So I said you produce JSON. Okay, well, presumably that means it should be able to parse. Okay, well, is it parsable JSON? Why or why not? What are the errors that you might have had? Are there ways that you could apply this in post, right? Is it considered not parsable into a particular object, but like actually, it just kind of every once in a while hallucinates this one little thing, and if we just remove that from the string, from the end user standpoint, it's like actually performing better. This is again, like you can say, we're gonna fix that in prompting or fine tuning a language model later, but right now we can improve the end user experience by applying some post-processing steps. You know what's really helpful? Understanding what those post-processing steps were and logging that stuff on a per request basis so you can say, okay, hey, it turns out that even though users are getting the thing that we want, a whole boatload of these requests are coming back with us having to apply programmatic fix-ups to the output. So maybe let's treat that as a bug and apply it the correct severity and say, okay, we're going to figure out how to solve this right now. Or maybe we're missing a post-processing step and we could then just add one and make the user experience a lot better. So there's a lot of opportunities there, but really what I'm trying to emphasize is there's a lot of important information that you should be able to capture and capture via your traces, and please do it. And then you can have something that looks kind of like this. Hooray, it's a trace. So here's some really small hot tips on analyzing this kind of data. I did mention it before, but there are triplets, as I'm calling them, from requests. Broadly speaking, what's the input? What's the error if it exists? And what's the response that I got back from the model? Like, there's a whole bunch of upstream stuff that you might want to care about. You might want to be able to look a little bit more at that. But even just looking at inputs, errors, outputs gives you like the ability to categorize with your eyeballs. Like, hey, looks like users are trying to do this sort of thing, and the language model is barfing all the time when we do this. Seems like a bug. Let's see if we can fix that and dig into a specific trace. and say, okay, what were the steps that we took for this specific request? Oh crap, it looks like we selected something that's definitely the wrong thing to select. Seems like the problem is not the model, it's actually us. Now we've gone from guesswork to like, I don't know, this non-deterministic system that I can't debug is acting weird, to, hey, look, here's a specific problem in our system that we can actually just fix right now and make the user experience better. You can also use SLOs to track what affects users, because kind of the whole point of SLOs is our system doing its job for the users? So like if they type a thing and they hit a button, does the system come back with like a working response? Does the UI fill out a certain way that it should fill out? You know, whatever sort of that successful output is, track that entirety of that end-to-end flow as an SLO and track it in terms of like errors and latency and so on, and like monitor, is it actually doing its job for users? And the reason why this is so critical is because, especially when you're getting into the nitty-gritty of prompt engineering, or God help you, fine-tuning your own language model, please don't do that at first. I've done this, it's very difficult. You're gonna do stuff that is going to fix a problem, and then it's gonna break something else that was already working that you didn't realize was already working. This is exactly what happened to me when I tried to fix stuff last year. And I was really happy that I tracked everything end to end in an SLO, so I can be like, oh wow, looks like this regression fix introduced another regression, great. If I wasn't doing that, then I would just have angry users at some point later, and I don't want to deal with that. So I do want to end with, you have friends in the ML engineering world. And I mentioned this before, there's a lot of overlap. All of these things that I've discussed, like, hey, we need to log every step that we're taking in retrieving relevant context, relevant information, log what the final like input to the system is, log what the output is, log what we did with that output. This is literally what ML engineers do, except they often do it with way worse tools than what we have. So they care a lot about things like production is the true test of how models perform. If you work with an ML engineer and you're like, hey, look at this, I got the model to do something pretty nice, they'll be like, oh, that's cute. Yeah, what it does in production is what I care about, because like everybody's doing weird stuff, and like I can't trust that it works on your machine is going to be good enough for me. They care about good instrumentation. They care about instrumentation from the application itself. Like if you go to an ML engineer and you're like, hey, I want to capture like useful info from the application to see what's going on in this system, they're not going to be like, I don't have time for this. They're going to be like, oh yes, please, finally, I've been waiting for someone to like care about this alongside with me. They care about their retrieval systems doing a good enough job. And again, like this is where like retrieval systems are just systems. You can make these things more reliable. In particular, they will use a little bit different of a terminology. And in fact, there's a little bit of a growing movement right now in this thing that we're calling observability for LLMs, or Gen AI observability, like insert keyword here. They are often saying the word observability to mean like looking at this kind of data, but in sort of like a development flow. And then there's sort of like and we'll sort of maybe figure out how we're going to do this in production, sort of connected to that later. This is where you come in, because they have tools where they're logging things in development, and they want to bring that to production. In their development environment, they have tests that they call evaluation systems, or evals. Evals they're really, really, really hard to build effectively, actually. And one of the best ways to build them effectively is to take, this is what my users are actually doing, and now I'm going to export all of that, and then I'm going to start annotating that with like, okay, user did X, response was Y. This is what response should have been. And then we're going to do that for, hundreds of times, basically, until we have a good enough system that's like, yeah, this is fairly representative of what users did at that time, and use that to say, okay, this is how it should be performing. Now we know how we can tune our prompting or our fine-tuning or whatever it is that you're actually trying to do. They also run what are called live evals. What we call them SLOs. It's basically just a function running on data based off of what's happening in production. That's literally what they want access to as well. And so, slight terminology difference, but basically the same thing that we're trying to do. So, if you are an AI hater today, I'm not here to convince you. You can still keep being an AI hater. But you can also be really, really useful to people too. And half joking, but kind of not half joking, y'all have a lot to bring to the table here to make these systems a lot better. And that's that.
All right. We've got time for a couple questions here before we finish out. Any questions? Rare.
So what's the accuracy you've seen initially, and then after tuning your prompts, model evolution from 4 to 4.0, all these things, like where have you started, where have you ended up?
Where's your efficiency gone?
So
Accuracy, yeah.
So like personally in my experience, since I started early last year, that was using GPT 3.5. We're still using GPT 3.5 in production actually. It's shockingly effective. It's a really, really good model. And we did start with, when we first launched, we did have an SLO that basically covered, user clicked a button, did we actually run a query that's considered valid by we have a huge set of validation steps. And I think it was something like 70 to 75% of the time initially, and then we got that up to about 96%, 90, 97%. There's a bit of a long tail also of people asking questions that are fundamentally unanswerable. So you can imagine you first instrument a system and it's working just fine, and then you say, what are my errors? Well, there's not even an error column in your schema at this point. So it's okay, I can't actually tell you what your errors are. So those are also situations that you're going to run into, and it's also really helpful to have good tools to differentiate between, did the user do something that we literally cannot answer right now, or did they do something that should be answerable but we just screwed up?
Yes. Question right here.
Do you consider AI hallucination a part of reliability, or is that a thing?
Do you consider AI hallucination part of reliability?
I feel like that's a whole discussion topic, because I think there's both a yes and no answer to that, because grounding responses in real factual information that you have validated is correct using retrieval is kind of a way to address hallucinations. It doesn't deal with it 100%, but you take something, let's say you had a system that was hallucinating 50% of the time, an effective RAG system could bring that up to bring that down to maybe more 5 to 10% if you're kind of maybe also depending on the domain. I do think though a lot of that does end up getting out of our hands though, because the reality is that GPT 3.5 is a pretty old model compared to what's out there right now, and for very good reason. They a lot of the model providers have been working very, very hard to sort of keep models grounded in fact, and it's sort of this weird problem that they have where they designed a system that is by design unreliable so that it can create so-called more creative outputs, and that's actually really, really useful. But then when your users are but I don't want you to say the false stuff, that's where it gets a little hard. You asymptotically maybe sort of approach zero, but maybe never actually approach zero. So I feel kind of going back to retrieval and grounding things in things that are actually true, this is definitely in the place where reliability can play. If you feel like you've maxed that out though, or you're this is taking so much effort to improve the retrieval system such that we might as well be fine tuning our own model, this is squarely not the job of anybody in reliability engineering anymore, I think.
If you get to the point where you're we should have our own model, then you need to stop and rethink everything.
I mean, it's fun fine-tuning your own model, but don't do that on your employer's time, like I did.
Awesome. All right, let's give a big round of applause to Phillip. Thank you so much.